Okay, we're going to take a look at relationships as measuring rate. And the activity that we are going to do in class, if you were in class, I'll just summarize what we did, is how fast is our class at passing out papers. So the rules for our passing out paper activity is going to be you need to stay in your seat, it must be silent, and once everyone at your table has their paper, you're going to hold it up in one of your hands. It doesn't matter which one. And then once we've done that, once we've recorded how many papers and how long it takes to do that, we're going to also time how long it takes to pass the papers back in. So we will have done that in class, and you will have data for that either from myself, or you can get that from one of your classmates. So in your math journal, we're going to be working in your math journal and the lesson worksheet. First of all, how do we measure the rate of passing out papers? So you want to, as you write the answers to this, you want to state the question as part of your answer and then record your answer. And every time I ask a question, it's always going to be followed up by the answer. So the best way to do this is to, on your math journal, you should have two columns. Write your initial response and in the one column, and then after that write, make any additions or write a completely new response in your other column. All right, so how do we measure the rate of passing out papers? Well, we are using a stopwatch basically, or a similar tool to measure the number of seconds it takes to pass out the papers. So that is our tool we are using to measure the rate. Well, what quantities will we use to describe our rate? So think about that. If we're passing out papers and we want to know how fast we are at doing it, what is the other part of the rate? And it is the number of papers passed out and the time that it takes. So how many papers and how fast or what time does it take to pass those out? All right, so in class we would take 2 minutes to discuss how to speed up both the processes before we do our activity again. And so that's what we've done in class is we pass out the papers, it's our second chance, and we time ourselves and we record that information. And then we pass the papers back in a second time also to find out how long it takes to pass in all the papers back to one spot. All right, now on your lesson worksheet, we're going to complete the columns labeled numbers of papers passed and time in seconds. So based on our activity in class, you should have that information to plug into your worksheet. Now we're going to switch over to your journal. You want to describe the quantities you want to measure by talking about what units we use to measure each quantity. So what are we using to measure the papers, and what are we using to measure the time that it takes? Well, the one quantity measures the number of papers, and the other quantity measures the number of seconds. So we're doing the number of papers to the number of seconds. So on your lesson worksheet, review the key idea box. Find that box on your paper, defining the ratio, rate, and unit rate, and use your highlighter to highlight the key terms and important phrases. This means that this is important when you go back to study for your assessments. You want to make sure that you focus in on these key terms and definitions. So do that now. All right, the next thing I'd like you to do is to complete the ratio column in the table on your lesson worksheet. So how are we going to write these as ratios? And again, this is just an example. If you already have data from the number of papers passed and the time in seconds, then go ahead and write the ratio. It should look like this. But if you don't have any data, then you can also use the information in this table to fill out your table on the lesson worksheet. When you are done with that, go ahead and continue the video. Alright, so back to your math journal. When we started passing the papers, the ratio was, and you can fill in the blanks, however many papers in however many seconds. And by the end, the ratio, so the end of our trials, the ratio was however many papers in however many seconds. So remember that the number of papers is constant, unless someone left the classroom, but we're going to assume that everybody was present. And hopefully the time decreased with each successive trial, because we got faster as we decided what would work in our passing of papers in and out. So are these two ratios equivalent? I want you to think about and explain in your math journal why they are equivalent or why they are not equivalent. So take a look at all of those ratios and are they equivalent or are they not? Well, you should have come up with something to this extent. The ratios are not equivalent since we pass the papers, the same number of papers in a shorter time. So we passed however many papers per second at the beginning and however many papers per second by the end. So equivalent ratios must have the same value. So if we did this faster or slower, then our ratios are not going to be the same. So which rate is the greatest? How are we going to determine what is the faster rate between the beginning and the ending trial? So in another class period, let's say that I've given you some more information. The students were able to pass 28 papers in 15 seconds and then 28 papers in 12 seconds. And a third class period passed 28 papers in 10 seconds. So how do we compare these to our class? So in your math journal, make some statements about, are we the fastest, are we second fastest, or how are we going to decide who is the fastest class and where our class is in that mix? Well, obviously in order to compare these, we need to find how many papers per second to make these comparisons so that everything is on the same, being compared the same way. So on your lesson worksheet, going back to our lesson worksheet, what I'd like you to do is review the meaning of rate and unit rate in the key ideas box and complete the last two columns of the table. So what's the difference between rate and unit rate? And use that to complete the last two columns. Again, this is an example, so based on the information in your table, your rate should look like this, 2 papers per second or whatever the rate is. And the unit rate, when we drop the descriptor, is just the number that's associated. So if this is 2 papers per second, then this would be unit rate of 2. So notice that now we're comparing it to each second. It's always per 1 second. So now we have an equivalent, or we have a basis of comparing which of these are fastest or slowest. All right, so in your math journal, we want to write this definition because it's very important as we continue our talk about unit rates. The associated unit rate is the numerical value A over B when there are A units of one quantity for every B units of another quantity. So remember, these are two different quantities and we are comparing one to another. When you are done writing that in your math journal, go ahead and continue the video. Alright, so let's take a look at another example. We're going to make a comparison of two quantities that are measured in the same units by comparing the ratio of boys to girls in this class to the ratio for different classes and the whole 7th grade. So in this class we have, and again each class is going to be different, so I'm going to leave it blank. Again, you can get the information from me or from one of your classmates. And in another class we're going to just use a standard information that there are 9 boys and 19 girls. So you want to complete example 2 table in the lesson worksheet according to the data that you are given. Again, this is just an example, but this is how I want you to write down. We have 2 classes, and then obviously you should have some information for the whole 7th grade. But when you write the ratio of boys to girls, it's going to look like this. All right, continuing on the lesson worksheet. We're going to consider the task, but we're not going to answer it yet. Create a pair of equivalent ratios by making a comparison of the quantities discussed in this example. So the example we're talking about is boys to girls. All right, so are the ratio of boys to girls in the 2 classes equivalent? Again, you're going to have to look at your table and decide whether they are or are not. The other thing is, what could these ratios tell us? So when you look at the ratios, what, if they're different, what are they telling us? And what does the ratio of boys to girls in class 1 to the entire 7th grade tell us? Are they equivalent? So again, I can't answer these questions for you. You have to look at the information on your table and be able to answer these questions based on your information. All right, so in your journal, we're going to copy down this particular example. This is just made up, so everybody's got the same information. So once you're done copying this table, then you can continue the video. But notice how we have some information for 3 classes, and we have the information for the whole 7th grade, but we're missing information for the 4th class. So is there a way we can come up with the answers to the missing class? So if there is a larger ratio of boys to girls in all of the classes, what can you assume about the ratio of class 4? Notice we have 5 to 9, 1 to 3, 5 to 9 again, and 5 to 9. So what can we assume about the ratio, this missing ratio? Is it going to be the same or more or less? And once you have that, determine the 4th class ratio and derive a conclusion about all the ratios. So is it going to be the same, 5 to 9, since we have that happening 3 times? Or is it going to be greater or less than 1 to 3? And how can we compare these? This looks very confusing. I can't tell which one is greater or less than another. So can we change this to make it more uniform so that we can compare them? All right, so this is what you should have come up with. If we know that we have 40 boys in the whole 7th grade, then that means the difference here would be 13. And if we had 72 girls in the 7th grade, then the difference here would be 15. And our ratio of boys to girls would be 13 to 15. Again, kind of hard to tell whether this is the same or whether it's different to the other ratios. So how do we compare ratios when we have varying sizes of quantities? How can I turn this into something that, again, compares this to where we can tell which is greater than or less than? Well, what we could do is finding a unit rate. In the data given here, the unit rate for classes 1, 3, and the whole grade is approximately 56 hundredths or 0.56, and the unit rate for class 2 is approximately 33 hundredths, and the unit rate for class 4 is approximately 87 hundredths. Well, where did these numbers come from? Where did 56 hundredths and 33 hundredths and 87 hundredths come from? Well, remember, if you write this as a ratio, this would be 5 over 9, and 5 over 9 is a fraction, and a fraction is a form of division, so you would divide 5 by 9 to get 56 hundredths. 1 to 3 would be 33 hundredths, and 13 to 15 would be 87 hundredths. So now we can tell which is the higher ratio and which are lower ratios. All right, on your lesson worksheet, review the key idea box, focusing on the meaning of equivalent ratios. So highlight if there's any key words that stick out for you and are meaningful, make sure you highlight those. Using the table from example 2, you're going to write down a pair of equivalent ratios comparing boys to girls, or a similar comparison from our class. So take 5 to 9 or 1 to 3 and write an equivalent ratio. What would be equivalent? 1 to 3 is like 1/3, so what would be an equivalent ratio to 1/3? All right, now we're ready to begin exercise 1. This is on your lesson worksheet, but you need to be prepared with this for tomorrow's class, and be prepared to share it with the class. In your answer, when you include this in your answer, you need to have a table that compares a pack of 30 and a pack of 12. You need to show in the table ratio, rate, unit rate, and unit of measure. So how are you comparing the two units of measure? And then you want a written description of the comparison between the two packs. So you're going to try this out, and again, you're just going to, attempting to answer this question in the way that you think it's going to answer it. It's not going to be a right or wrong answer, because you're having to make this up. But you want to at least attempt to include all three of these so that you have a starting point for our discussion when we are in class. All right, so once you are done with that, in closing and summarizing in your journal, this should be the last thing you do, is how is finding an associated rate or unit rate helpful when making comparisons between quantities? And one of the things that we did was create a unit rate. The unit rate tells the quantity of one unit required for just one of another unit. For example, a unit price of 4/10 means that one juice box from a 6-pack costs 40 cents. And that's just one example. But basically, it's finding how much something is for one item. So probably the best example is when you go to the store, when you buy a 6-pack of soda, how much is it for one can? All right, once you're done with that, that is the end of this lesson, and we'll see you in class.